Today we caught up on classifying triangles. So there were two major concepts from previous classes that we really stressed today. And they were, one, that all angles in a triangle add up to 180 degrees. So if you have a triangle here, and this angle measure is 70, and this angle measure is 70, what is this one here? Well, we can set up an equation in which we have all three angles in this triangle totaling 180 degrees. Now, I see a lot of you make this mistake, right? You'll add, 70 plus 70 equals 180, and that's not right, okay? So we're trying to find that the angles in a triangle add up to 180 degrees. So you need three angles added together totaling 180 degrees. If you don't have three things being added together in order to find the degrees in a triangle, then you have missed something, okay? So you need to make sure that you have three angles added together equal 180 degrees. And if we were to solve this equation, we would get the missing angle is 40 degrees. Okay, the other big concept that we went over today was that the angles in a straight line add up to 180 degrees, right? So remember when we talked about supplementary angles? If we have a line like this and we have an angle here, we can infer that this angle is 140 degrees because all of the degrees in a line add up to 180 degrees. Now, what else adds up to 180 degrees? Remember the transversal? A set of parallel lines crossed by a transversal creates two types of angles, big and small angles. The first thing we do is we label big, small, and then we know our equation, big plus small equals 180 degrees. Where else do we see 180 degrees? Think of a circle. The diameter in a circle is 180 degrees, okay? So these are all the places that we see 180 degrees. One more thing we need to go over are vertical angles. So remember when you learned about vertical angles are two intersecting lines that create two different sets of congruent angles. Okay? So we need to remember these four relationships, and we also need to remember that a straight line is 180 degrees. Okay? Those are the major concepts that we reviewed today. Then we did a practice problem on the board. Okay? So it says find your numbered angles, and we have angle 1, 2, 3, 4, 5, which are written over here. Okay? 1, 2, 3, 4, 5. So where do we start? We want to start in the triangle that has the most information, right? So let's start in this triangle right over here. It is given that this angle is 50, this angle is 78. We need to find what this angle is. So let's set up an equation. So for angle 1, we'll have 50 plus 78 plus x equals 180 degrees. We'll solve for x, and we'll get x equals 52. Okay? So the measure of angle 1 is 52. Oh no, that is not angle 1. That is just the missing angle in this triangle. So as soon as we get the information, we want to put it in the figure, right? So I'm going to put this 52 right over here. Now, angle 1 right here, you need to be able to make this connection. This is a line. So these two angles on the line, angle 1 and 52 degrees, when added together are going to be 180 degrees. Here, I'm going to redraw the line over here so you can see, okay? So angle 1 is right here, and then 52 degrees is the other angle. So these are all going to total 180 degrees. So let's set up an equation. We have 52 plus x equals 180 degrees. Subtract 52, and we get 128 degrees. Okay, so angle 1 right here is 128 degrees. So I'm going to put that in the figure. As soon as I get the info, I put it in the figure. Okay, so now we know that angle 1 is 128 degrees. So how do we find angle 2? Remember, we just reviewed vertical angles. You need to make the connection that these two are intersecting lines and they create vertical angles. So we can assume that angle 2 is congruent or equal to angle 1. And here we have the measure of angle 2. So angle 3, we only have one angle in this triangle so far. So we really do not know enough information in order to find this angle over here. So let's find angle 4 over here first, and then we'll work backwards, okay? So over in this triangle, we can see that angle 4 and this 120 degree angle form a line. So we can set up an equation, 120 plus x equals 180 degrees. Solve for x. We get x equals 60. Okay, so this is 60 degrees. We know that these are vertical angles, so we can put 60 up here. And now we have two angles in this triangle, and we could solve. Okay. So now we get 52 plus 60 plus x equals 180. So we solve for x and we get x equals 68. Okay, so now we have angle 3 is 68, angle 4 is 60 degrees, and now we need to find angle 5, okay? So we know these two angles in this triangle right here are 60 and 56, so let's set up an equation. We have 60 plus 56 plus x, this angle right here, x, equals 180. We solve, and we get x equals 64. So this angle here is going to be 64. So if we know that this angle here is going to be 64, how do we find the measure of angle 5? We do 64 plus x equals 180. And if 64 and x is going to be equal to 116. And we're done. So finally, when we review, an isosceles triangle has a set of equal sides and a set of equal angles across from those equal sides. A scalene triangle has 3 different length sides and 3 different length angles. Okay? 3 different length angles and 3 different length sides. And an equilateral triangle has all 3 sides equal and all 3 angles are equal to 60 degrees. An obtuse triangle has one obtuse angle and the other 2 are acute. An acute triangle has all 3 acute angles, and a right triangle has 1 right angle. And that's it.